All right, so in this video, I want to talk about mixture problems and how we're going to set those up because they're a little bit different and also not that different than from some of the things that we've already done. Okay, so the first thing we need to note is that the structure of mixture problems, remember we generally have two structures. We either have two things that equal each other or we have something that equals a total. And these will be usually something where we're mixing two things together to get a final mixture. So this is going to be a final mixture. Okay, the other thing I want us to note before we look at our first example is that when we come across percents in a word problem, we need to use the decimal equivalent in our equation. Sorry, this is not writing well. Okay, so for example, if we have 15%, then in our equation we will use 0.15. Remember that to change decimals over, percents over to decimals, we move the decimal place 2 times to the left. All right, so let's go ahead and dig into this first example that we have here. This one says, a lab technician needs 25 liters of a solution that is 15% for a certain experiment. But she doesn't have that. Okay, so she needs this descriptor. She only has a solution that is 10% and a solution that is 30%. How many liters of each should she mix to get what she needs? Okay, so just for the sake of you taking notes, we need to copy down these things that we just underlined. So will you put these 3 things in bullet points in your notes, so everything that I just highlighted in yellow? Okay, now for solving the problem, this is a similar structure to what I said. We're going to start with our structure, and that is I have 2 things that are combining to create a final mixture. Sometimes we refer to this as part plus part equals whole. Okay, so I know about my final mixture, that's what this first bullet point is, that I need 25 liters. This is my total amount, 25 liters, of a mixture that is 15%. Okay, and because percent says percent, per indicates that we're going to be multiplying. So I'm going to take that 25 liters and I'm going to multiply it by 15% here. All right, the other 2 percentages I know I'm going to have is a 10% solution, so I'm going to write that as 0.10, and a 30% solution. All right, so those are the 2 percentages. What I don't know is how many liters do I need of each of those solutions? All right, so if I call X the amount of solution of the 10%, I'm going to remember I need to define this variable. So X is the amount in liters of the 10% solution. And we could use a different variable for the other one, for this other spot right here. But the problem is if I use a different variable, then I can't solve it. I still need to use X. So notice I have kind of color-coded this here. In red, you will see these amounts are the actual volume that I'm looking for. So if one of them is X and the other one is 25, how would I find the difference? And we can kind of ask ourselves that with like a similar question. So I'm going to just scoot over here for a second. If I have something, if I have something plus something equals 25, let's pretend that I know that one of them is 12, for instance. How would I find this other one? Well, I would do 25 minus 12. That would tell me the other amount I need is 13. But in this case, I don't know that it's 12. I just know that it's some amount, which is X. So to find this other amount, it would be 25 minus X. So let's scroll back over here to our problem. The amount of this other solution that I need is 25 minus X, because 25 is the total, X is one part, so that would give me the other part. We are also going to practice solving these when we come into class, but right now I just want you to practice the structure. So skip some room so that we have some space to solve one of these, and then let's go on to our next example. All right, so in this one, we see, and again, you're going to write bullet points for this example too. I see Arabic coffee costs $28 per pound. Robusta coffee costs $8.75 per pound. And we want to create, this says, how many pounds of coffee must you mix with 3 pounds of, okay, so that's another piece of given information. We need 3 pounds of Robusta coffee. We want to make a blend that costs $15.50 per pound. All right, so you should have those 4 bullet points listed. Pause the video if you haven't already to do that. Okay, so now we're going to set up our equation. We've got a mixture of, and I'll even label this one. We've got this Arabic coffee, we have the Robusta coffee, and then we have a mixture or a blend. Okay, so the Arabic coffee costs $28 per pound. I don't know how much I'm getting, so I know that this is $28 per pound, but I do not know the amount. So notice in this one, and I probably should have labeled the last one, I'm going to do the, let's call this volume and the cost. That's the structure that we're going to do all of these. Volume times cost equals volume times cost. All right. The Arabic coffee so far, it doesn't tell me how many pounds. The question actually very specifically asks how many pounds, which means my Arabic coffee should be my X. All right, so X is the number of pounds of the Arabic coffee. Okay, for the Robusta coffee, they actually tell me how many pounds of Robusta coffee. This is 3 pounds of Robusta coffee, and they tell me the cost of Robusta coffee is $8.75. And then for the final amount, they know that the blend they want to cost is $15.50, but they don't tell me how much of the blend. They just know that they want that to be the cost in the end. So the volume here, the same, similar to the last one, I have X of one and 3 of another, which means my total volume is going to be X plus 3. And we're going to put that in parentheses just so we know that it stays together. Okay, make sure you have those examples written down, and we will practice this structure again tomorrow, and we will also work on solving some questions that are like this tomorrow.